Good morning, everyone. Woo. Welcome to day 3 of Snapdragon Summit. Before we begin, just a quick reminder, we are doing the Q&A on Slido, so please scan that badge and you can enter the chat. In just a moment, I'm going to welcome my colleague Ignacio Contreras to the stage. He's going to give you all the latest updates on Snapdragon Connect. But before we do, we got a quick video.
You made it. This is day 3 of the Snapdragon Summit, and this Tech Talk is for the passionate crowd, the one who cares. The story today begins about 10 years ago. I was attending a survival class, one of those when they teach you how to stay alive in the case of a major civilization breakdown, like a zombie apocalypse. And the instructor, when he came to the room, I was there part of the audience, he asked, what's the most important thing that you need to survive the most? People answer the classic things. You need water, you need food, you need shelter. Everyone was wrong. The #1 thing you need is air. Because with no food, you can survive several weeks. With no water, 3-4 days. With no air, you cannot go longer than a few minutes. Connectivity is the air that gives life to our user experiences. It's invisible. You don't see it. You don't think about it unless it's lacking, unless there's something wrong, and then immediately notice this. Another story. Many years ago, I was working in my home country in Chile for a land surveying company, and we had a meeting with an important mining company in the Andes. This was like 10,000 feet high offices, like about 3,500 meters high. So we went and drive up to this meeting, and of course, with the lack of air, I was there sitting in the boardroom. My eyes was like big red, like balloons, and I was very short of breath, like in my meeting. That's your phone when it doesn't have the right technologies to connect. That's the experience that your phone is trying to do when it's lacking the connectivity. That's why we put so much emphasis at Qualcomm, so much investment, so much R&D, so much product development engineering in connectivity, because that's key at the end for your premium phone experiences. And the best of our connectivity is Snapdragon Connect. When we talk about Snapdragon Connect, we talk about best-in-class wireless technology. We talk about best-in-class 5G, Wi-Fi, and Bluetooth. And all the technologies that we put in our suite are focused on 4 goals: to give you faster speeds, not just the peak speeds that you get, but also faster speed in challenging network conditions, like a crowded room or when you're far from the access point on Wi-Fi or the cellular base station. we also put a lot of technology to make connectivity more responsive. Less delay, less latency for things like cloud gaming, for things like video conferencing. We also delivered a number of technologies to increase coverage, because coverage is not just a function of the network. It also depends on the device and how capable is your device of reaching out to that cell tower or to Wi-Fi access point. And of course, all of this with tremendous emphasis on power efficiency, because that's a top requirement for any premium phone buyer, that the phone can last at least a day or longer. So let's go in this journey. We'll now shrink this room and go into a silicon level to understand what makes Snapdragon Connect within the new Snapdragon 8 Gen 2 the best-in-class connectivity you can get across 5G, Wi-Fi, and Bluetooth. If we start peeling, right, the system and look inside what is creates or what makes up a Snapdragon 8 Gen 2 platform, we will see two systems that are responsible for connectivity. We have the Qualcomm FastConnect 7800 system, which handles all the Wi-Fi, now Wi-Fi 7, and Bluetooth connectivity. And we also have the Snapdragon X70 5G Modem-RF system, which manages 5G, all cellular technologies, in fact, but also manages, many people don't know, location capabilities, your GNSS, how to resolve where you are in Earth using your phone. So let's look deeper. Let's go into the 5G Modem-RF system. With the new Snapdragon, we are raising the bar yet again with what makes the benchmark for 5G. This is our second generation where we are enabling, again, 10 gigabit 5G class experiences, fiber-like connectivity for your device. But also, more importantly, we are adding a significant amount of AI technology with the first AI processor that runs within the 5G Modem-RF system. We're using AI across the Modem-RF system to increase performance on a number of vectors, in terms of speeds, in terms of coverage, in terms of power efficiency. This is enabled by our 5G AI suite and a number of technologies. Let me describe you a few of these. AI-enhanced channel state feedback. What is this? All your 5G phones that you're carrying right now are always sensing the RF environment. How good or bad are the RF conditions? And they're taking that information and sending that information back to the base station, to the cell tower. So the cell tower, it's always collecting all this information from the phones in the field and using that information to schedule the spectrum resources, the time of sending and receiving signals, to optimize overall the performance of all the cell phones in the site. What's the problem here? The problem is the speed of light, because it takes time to send this information from the phone back to the base station. So what we're doing now with the new Snapdragon and the AI capabilities is we're using prediction. We're predicting, not reading, what are the RF conditions at any point in time. So we predict what will be the RF conditions 1 moment after we send that information back to the cell tower, to the base station, so the base station have more current information, a better reading of what's going in the field in that moment, and it's able to improve the performance of the overall 5G system. We're also using AI for mmWave beam management. Anytime you are connected to mmWave with your phone, you are linked to the base station, but also your phone is managing a number of beam candidates, different beams that one of them will pick up the connection. As you move around, and it's better, sometimes you use a reflection, sometimes it's better to use direct line of sight. Now we're using AI to predict what will be the next beam. So as you move around, we are able to predict what will be the best beam to use for mmWave at any point in time, and use that beam and improve the overall performance. we're using AI as well to understand to which base station, which cell tower is better to connect and improve overall performance. We're using AI to understand how you're handling your phone, and based on that, tune the antennas accordingly. We're using AI to understand if you have direct line of sight to the GNSS satellites, GPS, Baidu, Galileo, and others. And if you're having line of sight or not, we take that information in consideration to improve your positioning. So overall, you see how we're using 5G, not just across the whole Snapdragon platform, but also extensively into the Modem-RF system. This is unique to Qualcomm. This is unique to the new Snapdragon. Bob O'Donnell.
Yes, sir.
This is for you. I know you care because I know each time we're talking, you ask me, okay, how is this relevant for the user? How is it relevant for the USA Today reader, right? That's not necessarily just living and breathing technology. This is for you. We have been testing the new Snapdragon with the AI capabilities using our reference platform, and we have seen in sub-6 speeds using sub-6 spectrum up to 20% improvement in the performance, in the throughput that we see with data. We have also used the same test to read up to 25% improvement in mmWave reliability. So you connect better, whether you have line of sight or if there's foliage around, you can connect better to the base station. Overall, we're seeing significant improvements, and this is important because it's not just throwing more components and more silicon to the problem. We're using the information that we have more intelligently with AI. But the innovations don't stop there. With the new Snapdragon, we're also introducing our third generation of Smart Transmit technology. Smart Transmit is a technology that optimizes the uplink, the transmissions when you're sending information from your phone, from your device to the cloud, in a way that we maximize the performance, but always staying within the RF limits that ensure or back your safety. In that sense, a few years ago, we introduced the first generation of this technology to be able to handle all cellular technologies, 2G, 3G, 4G, and of course, 5G. A year later, we introduced the capability to manage multiple antennas. So your phone and Smart Transmit can operate along about dozen of antennas that your phone has in your purse, in your pocket, and be able to optimize the performance. And this year, we're introducing the ability not to manage cellular technologies only, but also to manage Wi-Fi and Bluetooth. So we take in consideration all the transmit components across all cellular technologies, across Wi-Fi and Bluetooth, and optimize those to have the better uplink performance, better reach, better speeds. This is a key example on how you can do these kind of technologies if you master all of them: 5G, Wi-Fi, and Bluetooth. And when we talk about mastering all these wireless technologies, 5G, Wi-Fi, and Bluetooth, we're talking about Snapdragon. Furthermore, the new Snapdragon is the mobile platform with the most comprehensive set of spectrum aggregation technologies. If you think that connectivity is the air for our mobile experiences, spectrum is the oxygen. The more you can get, the better. The better performance, the better speeds, something better coverage overall, so you need more spectrum. And we pioneered the aggregation of a spectrum across different frequencies about 10 years ago when we launched the first Snapdragon 8 series. And we have kept evolving this, and now we have the most comprehensive spectrum aggregation support with this new Snapdragon with things like 4 times carrier aggregation, so we can aggregate up to 4 carriers in sub-6 spectrum. We can also aggregate carriers on the uplink for better performance when you are sending information back to the cloud. We also manage switch uplink, which uses opportunistically the FDD spectrum to complement TDD spectrum and be able to improve performance. And also we're able to bring together 5G, mmWave, and sub-6 spectrum. All of this translates into the fastest 5G speeds that you can get on Earth with Snapdragon. But also, it's not just about the peak speeds. It's also how you can improve the performance in challenging network conditions when you are at the edge of the cell tower. With better carrier aggregation, we can use the frequencies that we have available in a best manner and therefore improve overall your coverage and performance. This is the reason why maybe you are in the stadium full of people trying to access the network, and you are the one who is able to post that picture or that video in social media while the person sitting next to you cannot. And here we have a demonstration of what the new Snapdragon is capable of when we aggregate spectrum. In this example, we are aggregating 100 megahertz of sub-6 gigahertz spectrum with 800 megahertz of millimeter wave spectrum to achieve more than 8 gigabits per second. This is an over-the-air test with real infrastructure, our mobile platform testing solution. This is a real Snapdragon X70 Modem-RF system operating. And here you can see we can achieve that number, 8.4 gigabits per second. You might know that with wireless technology, it's always very difficult, is theoretically to achieve the maximum speeds, right? But here you can see how in a test we can reach more speeds that our competitors can do in their specs because you have Snapdragon. And this is important not just because of the peak speeds, but also in a crowded environment, you can access the network and be able to maintain a seamless connectivity while others cannot provide that. And if you want to see this, right, in real life, Verizon has made available in this venue, in particular in this room, probably what's the best 5G network available in the world using millimeter wave and all these bands. So if you have a millimeter wave phone with Verizon, you're able to do a speed test right now and you will see the capabilities. And if you don't have one phone with millimeter wave, maybe you can ask your mom to give you a Snapdragon phone with millimeter wave for the holidays. We're also proud to say that Snapdragon with the X70 Modem-RF system is a truly global solution. It supports every 5G network in the world with the most comprehensive set of frequencies that we support. And we also support global multi-SIM 5G plus 5G DSDA capabilities. This is like having two 5G lines, two 5G subscriptions in your phone. So you can, for example, be playing a cloud game title in using one 5G line and talking to a friend or texting with a friend in the other line, all simultaneously, all using two subscriptions in just the same phone for the first time, now with Snapdragon. But of course, things don't stop there. Because I'm pretty sure that, I know, Carolina, when you are at home, that's probably the place that you love the most, right? With your husband and your kid. And sometimes, yes, I can say the same. But that's basically when you're using, at the end, Wi-Fi technology, because Wi-Fi, it's important for those places where you live the most, your home, your workplace. And that's where we bring, for the first time, to our mobile platforms, Wi-Fi 7. Wi-Fi 7 is the next generation of Wi-Fi that will enable more smoother connectivity in those places where you live and you love the most for applications like cloud gaming, next generation VR and XR, collaboration as you work in video, and much more. You can think about Wi-Fi 7 as a professional air purifier for those places that you love. So the oxygen, the air will be better, connectivity will live better at your home, at your office, and you will be able to have smoother user experiences. In the new Snapdragon 8 Gen 2, this is powered by the Qualcomm FastConnect 7800 system. This offers the fastest global Wi-Fi speeds, 5.8 gigabits per second without 6 gigahertz. But why we say global? Because you will see soon why in regions where there's no 6 gigahertz spectrum available, this is the only way you can achieve meaningful improvements with, versus Wi-Fi 6, up to 4.3 gigabits per second. We are also have optimized our solution to offer the lowest latencies possible available today in Wi-Fi, down to 2 milliseconds. And yet again, we have optimized the full system to improve efficiency, to be able to give you more battery life for the experiences that you love. Wi-Fi 7 brings a number of key innovations that allow us to offer better connectivity in those places where we spend the most time. We are now introducing 4K QAM modulation, an advanced modulation scheme that allows you to pack more bits and bytes in the signal and get more performance. I said before, spectrum is like the oxygen, right, in your mobile experiences. Wi-Fi 7 allows us to work with double the spectrum that we have used with Wi-Fi 6, going up to 320 megahertz channels, double of the previous generation. And a key capability that Wi-Fi 7 is introducing is the ability to operate multiple links. So you can use multiple links across the 2.4 gigahertz spectrum, 5 or 6 gigahertz spectrum. You can alternate them, you can use them simultaneously, and this is where you will see a major differentiation that we have enabled with the Snapdragon. This is called high-band simultaneous multilink. What this means? Remember when we talked about carrier aggregation in 5G? Now we're bringing the same capability to the Wi-Fi world. We can now use two high-band channels simultaneously, whether it's 5 or 6 gigahertz, and aggregate a spectrum, let's say two 160 megahertz channels, to be able to create a virtual and more effective pipe of 320 megahertz of spectrum. This allows us to have better performance, better speeds, lower latency, so it's better responsiveness. And since we are only using, in this case, with high-band simultaneous multilink, only the 5 or 6 gigahertz spectrum, we're releasing 2.4 gigahertz spectrum for those Wi-Fi IoT or Bluetooth devices that are around you that also depend on good connectivity. A few months ago at IFA, we demonstrated the first high-band simultaneous multilink connection, aggregating two channels across 5 and 6 gigahertz to achieve 5 gigabits per second of throughput. This is the same that you can get with fiber. Now Wi-Fi is getting faster than maybe the fiber link that you can hit in your home, not to talk about cable or DSL. But more importantly, and this is where Snapdragon offers major differentiation, in countries where there's no access to 6 gigahertz spectrum, we can use the same technology, aggregating spectrum across 5 gigahertz, in this case a total of 240 megahertz, to offer speeds north of 3.4 gigabits per second. This is 50% faster than you can achieve with Wi-Fi 6. And this is only possible to do in a meaningful way when you use high-band simultaneous multilink. It's only possible to do today with Snapdragon. And there are more tricks under the sleeve. We can also use high-band simultaneous to connect not just to the same device, but to two different devices simultaneously. Let's say on one end, we're talking to the Wi-Fi 6 or 7 access point, and on the other end, we're talking to a device like an AR glass. This brings tremendous possibilities for new applications and new uses on Wi-Fi. To speak more about that, please welcome my good friend to the stage, Fred Kim, Director of Product Experiences at Qualcomm.
Good morning. As we've learned over the last several years, connections are invaluable. As Ignacio mentioned, we likely underestimated and undervalued those connections until we realized how important they were. Wi-Fi is no different because we need reliable, high-quality connections in order to play, stream, and surf. Now, there are new use cases and experiences on the horizon, so we've unlocked Wi-Fi. And so I'm going to talk about one use case in particular, augmented reality. Wireless AR is a certainty. With VR achieving new wireless capabilities, wireless augmented reality is not far behind. Yesterday, we heard about AR2 bringing new capabilities to the glasses. Today, I want to talk about what those glasses are connected to and how, namely your smartphone or PC, and how central those devices are to the experience. So I'm sure many of you have multiple displays at home. Indeed, I have a colleague who brought an extra display here to Hawaii so that she could multitask. So imagine being on a video conference call with your smartphone, and instead of using a separate display, using wireless augmented glasses in order to see virtual displays, complementary content, and maybe even navigation directions to your next meeting. So let's look at the experience as it is today. You could connect in two ways. The first would be to have a high-band connection from your access point to your smartphone, and an alternating high-band connection from your smartphone to your glasses. Now, this wouldn't work because your glasses need to display, process, and render information in real time every time. Introducing an inconsistent connection means latency, degraded quality, and an overall poor experience. The second option is not much better. You would have a low-band connection from your access point to your smartphone, and then a high-band connection from your smartphone to your glasses. But in this case, you've just degraded your Wi-Fi 7 smartphone into a Wi-Fi 4 phone. And that's just not tenable. So the only way to solve for this is to have high-band connections to both devices at the same time. High bands ensure that you're getting high throughput and low latency so that you can continue to use your phone while doing AR. So let's look at what this means when you have peak performance. Content is being rendered on your smartphone. At the same time, it's being done on glass. And in this case, phone-to-glass latency is critical. Indeed, you need ultra-low latency in order to process information that's in sync and consistent with your movements and surroundings. In order to handle this level of real-time processing, your phone and devices need the best possible links. High throughput means you're getting uncompromised, high-performance connections to your phone, your AR experience, and anything else that you're doing. So the throughput that you're seeing here, approximately 200 megabits per second, is in an uncongested network. But we all know adding more devices to the network introduces latency. Being in the high bands, though, you're getting 10 times the max throughput so that you can have a smooth, consistent AR experience and still use your phone for everything else that you do. Now, HBS multi-link technology for AR is an amazing leap forward, but we're considering many other use cases. Wireless docking, as an example, where all your home office peripherals are connected. Social gaming, playing an 8K multiplayer game and connecting to your TV, to your game controllers and your audio devices, as well as low latency enterprise collaboration. where your conference room AV equipment is connected to your phone and you're controlling everything from there. Now, these experiences are made possible by HBS Multilink, and they're available here today on FastConnect 7800. Back to you, Ignacio. Thank you.
The question now, for those arriving late, is when? When will we see these capabilities available in our hands? I'm very happy to report that now Xiaomi has stated that they will implement Wi-Fi 7, including high-band simultaneous multi-link, in upcoming flagship devices for the globe. So this is sooner than you expect. It's not years, it's not months, maybe in a matter of weeks, that we'll be to experience as a consumer, as a user, the benefits of Wi-Fi 7 with high-band simultaneous. And now we enter into the last chapter of our story. We spoke about 5G, we spoke about Wi-Fi, but also it's important to talk about Bluetooth, because Bluetooth is the de facto discovery mechanism that we have to pair and connect with the devices and accessories around us. Could be our watch, could be our earbuds, could be the car fob, could be the pet tracker, like I use with Mac, my dog. And that experience, it relies on the capabilities of Bluetooth. It relies on the reach, right, or how much range you can have with your Bluetooth solution, how easily it can pair with other devices, and of course, as always, with the power efficiency of this system. To make things even better with Bluetooth, enter dual Bluetooth. This is a unique capability in the FastConnect 7800 that power the new Snapdragon, because it allows us in a device to manage not just one, but two Bluetooth antennas simultaneously. How does it work? When you have a single traditional Bluetooth connection, there's just one antenna that's sending back and forth the information to your device, let's say your earbuds. The challenge here is that this is susceptible, it can be challenged by interference. Let's say you put your hands there and that the signal is attenuated, and therefore it's the experience, the audio can be degraded if not cut off. Last year, we introduced an innovation on Bluetooth, smart antenna switching. So we read the state of the Bluetooth connection, and you can use two antennas and switch from antenna A to antenna B if we sense a degradation in the signal to be able to maintain a robust link to your earbuds or any other Bluetooth accessory overall. But now we're taking things to the next level with dual Bluetooth. Dual Bluetooth allows us, for example, to use one antenna for the transmission to connect and send back and forth data with our earbuds, and use the other antenna to continually scan for other devices. You can discover more easily maybe a smartwatch or other device that might come around you. We're also using the two antennas simultaneously to receive the same information, the same packets from any Bluetooth signal simultaneously. And that allows us to better resolve the signal, the data transmission, and be able to extend the range to which, let's say you are receiving a phone call. You are speaking through your voice in your headset, and the phone is better able to receive that signal using the two antennas simultaneously, and therefore extend the range. And another trick, similar to what we use on mmWave, we're using the two antennas simultaneously for beamforming. This means that we use the two antennas to concentrate the energy of the Bluetooth transmission into one signal direction, pointing to the devices, and therefore be able to extend the range as well. So you can leave your phone behind, and just you can walk around with your earbuds on your home, and the signal doesn't cut off. You can just have more freedom within the space that you love, using the accessories that you love. With dual Bluetooth and other optimizations and improvements in our Bluetooth solution, we're able to offer superior Bluetooth experiences. Up to twice the range that you can get to connect with your Bluetooth devices, and up to 50% improvement in power efficiency, so your devices last longer. And of course, we're introducing the latest on the Bluetooth specifications, Bluetooth 5.3 and LE audio, which will be discussed extensively in the Snapdragon Sound session coming right after. So now you know it. Now you know why Snapdragon Connect and the new Snapdragon 8 Gen 2 is able to provide more air to your mobile experiences. It's a collection of technologies going from AI, spectrum aggregation, smart transmit, Wi-Fi 7, dual Bluetooth that allow you to bring more fresh air and bring more life to your smart devices. Thank you so much, and I look forward to getting your questions. I'll invite back Fred Kim to the stage and our Vice President of Product Management, Francesco Grilli, to help answer any questions you may have.
As a reminder, the Slido QR code is up on the screen, so please scan it and start entering your questions. We actually don't have any questions yet, guys.
Very thorough.
I can start calling people randomly. I can do that too. Bob?
So, dual Bluetooth looks great. Why is it taking so long for that technology? And I'm not saying Qualcomm, but in general, it seems like such an obvious and great improvement. It just seems surprisingly stable. Curious as to why.
Yeah, okay. I can try to address that. So, what we have improved the RF performance of Bluetooth by extending the range and increasing the reliability with the multiple antennas. However, the protocol that Bluetooth is using to negotiate between client and server, that one has to basically always downgrade to the lowest version which is understood on both sides. So even if you have the latest Bluetooth implementation in your smartphone, if you are connecting with a device which doesn't support the latest protocol, then you have to basically talk, at least on the signaling side, at the lowest possible level. And so that sometimes may take longer. But of course, once more and more devices get upgraded to the latest version of Bluetooth, things should become faster as well. So it's a signaling versus RF performance issue. So we can improve the RF performance all we want, but of course we need to be compatible with the devices which are still a legacy.
Great, thank you. Just a quick reminder, when you guys are entering Slido, if you could use your first and last name, that way if for whatever reason we can't get to your question, we can follow up with you afterward. But first question, when do you foresee Wi-Fi 7 to start massively increasing?
Starting before the end of this year, we'll see Wi-Fi 7 appearing. Wi-Fi 6 already, it represents more than 50% of the shipments overall Wi-Fi devices, but now the transition begins. It takes a couple of years, but again, it's a matter of not years, not months, but weeks when we start the transition to Wi-Fi 7.
Okay. In which application and field do you think the penetration rate of Wi-Fi 7 will increase the fastest?
I think certainly in the enterprise, we're seeing devices being launched on the access point side now, and we'll certainly see those as well on the consumer side. And eventually, of course, we're going to see devices like Snapdragon 8 Gen 2 with FastConnect 7800 coming.
Yeah. Also, for the home, you have these products with the mesh network that actually can benefit from the fact that now you can use, at least in some countries, 6 gigahertz, like Wi-Fi 6E. Now you can do that even with a larger bandwidth to basically use a new spectrum to essentially offload the backhaul functionality to a completely new band without interference, which is actually great for the performance. So so those tend to be a little pricey, but they are going to have very good performance. So mesh systems for the house, I think they're going to benefit from Wi-Fi 7 quite a bit.
Great. How are your dual Bluetooth solutions different from competitors?
I'll take that. You need to put more hardware at the end to manage dual Bluetooth. It's not a software enablement. You need to have two modems to change that manage the Bluetooth antennas to be able to enable this. Competitors might be able to do this, but they have not. So until then, you have a better solution with Snapdragon.
Yeah, so in general, when you have two receive antenna, it's always better than a single receive antenna. When you do maximum ratio combining for the experts here, you always gain 2 to 3 dBs if the antennas are not correlated too much, which is the case for the Bluetooth antenna. So it's actually, it is something that is well known in the industry, but it is actually difficult to implement because you need to do extra processing that so far was never done for that particular waveform. And so that is, it's important to be first.
Okay. The aspect of Connect that wasn't discussed is Bluetooth security. There have been issues with the protocol in the past, so what sort of evolution on security is needed?
Yeah, we might have to go deeper offline on that, but overall, yes, we put a lot of emphasis on security across all links, 5G, Wi-Fi, and Bluetooth, and we're constantly providing updates to our OEMs to be able to make sure that they are capable of managing all the major security risks.
If a smartphone has Snapdragon 8 Gen 2, what are the mandatory feature sets connectivity-wise that we can expect? Dual Bluetooth and Wi-Fi 7 with HBS are built in.
We never have mandatory feature, right? So the customers always have the choice to pick and choose. So it's like in a restaurant. So Qualcomm will offer the menu to the customer, but the customer, the OEM, will actually choose what to eat, right? So it is, so we make available the technology, but it's up to the customer then to decide to deploy because they may have business reasons why they may not want to deploy all the technologies, like for example, market segmentation. They may deploy only the top, on the top tier, the most advanced technologies, but in the lower tiers, they may not deploy all of them. And also because they may have legacy industrial design constraints. So if they don't have room for a 6 GHz antenna, for example, then they may not be able to implement it. So it really depends on, nothing is mandatory. They will, of course, get all the performance from the modem enhancements, all the performance improvements, but they don't have to sign up to any specific feature deployment, right? So that is always their choice.
Yeah, but for a device maker to feature the Snapdragon Connect in their presentations or the package or anything else, they have to meet a number of requirements in terms of the capabilities they're incorporating. So if you go to the Snapdragon Connect webpage, you will see that list of requirements like Wi-Fi 7 high-band simultaneous, ability just to manage antenna tuners, and some advanced capabilities on 5G and Bluetooth as well. So we can share that list, and when you see a device featuring the Snapdragon Connect logo, it means that you have a device maker that has gone long ways to bring the best of 5G, Wi-Fi, and Bluetooth.
Okay, you kind of answered the next question. Is HBS multi-link a feature that OEMs have to opt in and offer in their handsets, or is it available with any Snapdragon 8 Gen 2 mobile device?
I think Ignacio just answered that.
Yep. It was upvoted, so I wanted to make sure I got to it.
Yep.
Next one, I would like to confirm, does Wi-Fi 7 implementation need discrete 7800 chip? If an OEM vendor doesn't choose 7800, does 8 Gen 2 support Wi-Fi 6?
Well, our Snapdragon platforms are a set of components, not just one chip. It could be up to 40 components that make up of that platform, right? And part of that platform of the Snapdragon 8 Gen 2 is the FastConnect 7800. If you don't have that, Another chip might have be able to possible, but with Wi-Fi 6, 6E capabilities. But our offering and integral part of the Snapdragon 8 Gen 2 in terms of a full chipset is FastConnect 7800 with Wi-Fi 7 capabilities.
But in any case, you cannot. It would be foolish to have both implementations in the separate chip and in the main chip. So essentially, you cannot expect that without the dedicated Wi-Fi 7 chip, it will be able to work in any other mode, right? So.
Okay. Do you have any plans to bring Wi-Fi 7 to your compute platform, like a refresh of the Snapdragon 8 CX Gen 3 with Wi-Fi 7?
We can't comment on our future roadmap, but certainly stay tuned.
Okay. Will Qualcomm make any Wi-Fi 7 routers? You seem to have Wi-Fi 7 chips, but no routers on the market.
We already launched our first series of Wi-Fi 7 chipset solutions back in, I think, April or May, the Networking Pro Gen 3 series. And there are a number of, at least one or a few companies that have announced solutions based on the new Wi-Fi 7 chips for access points. And yes, when I mean that Wi-Fi 7, the transition will start very soon, it's on both ends. It's on the devices, but also on the access point side.
TP-Link launched Wi-Fi 7 routers on Monday that are based on Networking Pro series.
Very timely. Thank you, Lauren.
Any chance for ultra-wideband tech replacing Bluetooth or having low-energy Wi-Fi to ease transfers between device and get rid of Bluetooth cons?
I think that, so Wi-Fi is looking at lower power and implementations. The problem is that it's an ecosystem issue. So you have, for wearable and for hearable devices, you have always legacy products. And so it is going to be a challenge to essentially to switch to a completely new technology. So there is a lot of stickiness in the ecosystem to stay with Bluetooth-based for some category of devices. And so the same reason why Wi-Fi and cellular continue to coexist, even though you can do small cells in the home with the cellular, but still Wi-Fi is supported in more devices, in like a TV or other devices that do not support cellular. So in principle, on paper, it could be done, but in practice, I think it's going to be very challenging because the ecosystem is quite sticky to the legacy technologies.
Yeah. And overall, we're also always looking at what wireless technologies are commitments to offer the best with the Snapdragon, of course.
With the enhancements made with 8 Gen 2 for mmWave, is there also a new generation of mmWave antenna modules? If so, what are those enhancements?
Yeah.
Okay, so mmWave, we always continue to improve the antenna modules, and so there is a change on the RF front end, not only for the module themselves, but also for the IF and baseband component. And so that part, we do not go into a lot of details, but it is really, there is a lot of innovation in that area. So in the end, for the end devices, we always have a wide range of possible solutions, and so it's up to the customer to choose the most appropriate mmWave module. But in that area, we continue to upgrade and to introduce a new capability, like, for example, new mmWave bands that are becoming available in countries around the world. So we did not discuss specific details on the mmWave module, but that you will be able to find in our material on our website.
How big is the advantage you're getting solely from using AI in the X70 modem in the sub-6 frequency range?
Okay, that's very, very good. Okay, so once, as Ignacio was showing that it's like 20% for sub-6, actually you can go much higher than that. So 20%, I would say it's an average throughput and capacity improvement that you get. So once you do use AI, essentially you are making a prediction about the channel state in the future. So as you know, in the way cellular communication works, even if you are relatively static, your channel will fluctuate very quickly, and the base station will try to take advantage of that, of assigning you resources when the channel is good for you, and assigning resources to somebody else, maybe be next to me, when the channel is bad for me but good for him, right? So this process is called the channel-sensitive scheduling, has been done for a long time, starting from more than 10 years ago. Now, that is based on feedback, but that feedback, as Ignacio was explaining, is subject to speed of light limitations, and, but the channel sometimes changes so fast that it's actually beneficial to predict where the channel is going to be in the near future. And in principle, you could do that with algorithm, but it's going to be very complicated. So what you want to do, you want to use a neural network to be able to use past experience to predict where the channel will be a few milliseconds into the future. Once you do that, you actually, you are giving the device, the channel, the resources when the channel is at its best. So you are going to improve the overall efficiency of the system and the peak throughput of the device. So as Ignacio said, let's say 20%. So 20%, think about from an operator point of view. So if you paid billions of dollars for a spectrum in sub-6, like Verizon paid $40 billion for the band C spectrum, well, 20% improvement of something that you paid $40 billion is a lot of money, right? So it's $8 billion basically extra capacity that you get on the system. So it's very significant. So whenever I'm a product manager, whenever I consider a new feature, a new product, I always look at how much does it improve with respect to the current generation. If it is above the 15%, it's a big deal. So in our industry, whenever you improve something more than 15%, it's really a big deal. And so having this capability in our products is actually going to be quite useful, not only for the user that will see 20% on average higher data rates, but also for the operators that will see when those devices are widespread with the new AI capability, they will see a 20% increase also in capacity in the sub-6, and if they paid a lot of money, it translates into a lot of extra assets for them.
Okay, we have time for one more. There's actually a couple on this topic. Power consumption for dual Bluetooth and Wi-Fi aggregation. Can you discuss how we achieve this?
Well, with Bluetooth, in fact, you can use Bluetooth to save power, for instance, in the reception, to the extent that you are receiving, better receiving the signals from the Bluetooth device, right? You need less repetition overall, or where you're focusing the energy. You can always either increase the range or reduce the level of energy that you are using to reach out to a particular device. So anytime that you're using multiple antennas, yes, it requires more processing, but also, particularly on the transmission level, you can reduce power overall.
All right, that's it, everyone. Thank you very much for attending this session. If you have additional questions, we encourage you to try to set up some one-on-ones, or we can follow up offline. In the meantime, enjoy the rest of Snapdragon Summit.